Okay, welcome everyone. Thanks for coming. Yeah, so I'm David Moore. I'm a faculty member here with nuclear and particle physics, not an accelerator, but kind of precision experiments for the Great Lab. So I'll be giving you a whirlwind tour of writing and publishing papers and abstracts. So the theme of this talk is always PhD comment. So here's the PhD comment on how you write a paper. You know you have to translate your thoughts on the screen, right, and then you just press your head against the screen and translate. So we hopefully have some strategies beyond that, but you can try that out. So why do you want to publish papers in the first place? Well, it's really how we convey our work to other people in the scientific community. And, it allows other people to understand your results and maybe replicate them. It's a really key part of science. And you're adding to a continuously growing literature in our community. So this is actually a kind of cool plot of a century of physics papers. It's just showing the number of papers versus year here. And you can see it follows this kind of power law, Moore's law sort of trend, and hitting something like 1 million papers here in the current era. You keep extending on into this later. And the doubling time, it turns out, if you fit this line to it and maybe exclude these wars and other major global events, is something like 6.5 years. So there's a huge body of scientific knowledge that you'll be contributing to with your work, and this is how you contribute to it. And then more practically, it's an important part of your career. You have a CV with all your publications for getting jobs and stuff. Publications are a big part of it. So how do you get started? I mean, really the hard part is the idea and the science. That's always really the work, but then maybe this talk is more about the mechanics of taking that science and getting it into a publishable form. So getting, together with your research group, your advisor, coming up with an idea, data, measurements that you take in the lab is really where most of the work is, and where you get a good paper is in what you're writing about. And one of the tricky things is always to know when something, especially when you're starting out, when something is publication ready. Often, like, the perfect can be the enemy of the good, and you always want to do a better and better experiment, but you have to find logical places to stop in your research. No research question is completely, ever solved in a single paper. And talking to advisors, senior folks in your group, other students can help you know when something's ready. Assuming you know that, the next thing you do is you pick where you want to publish it. This is, again, a very kind of field-dependent topic. Depends on your research exactly. Here's some ones I've listed for physics that we use a lot. I've actually colored them by for-profit and nonprofit, which may or may not be a concern to you, but for some of us, we like to think about it. Many of the journals, the ones here in blue, are run by nonprofit organizations like the American Physical Society, the American Institute of Physics, Institute of Physics, but some, including very famous ones like Nature, are for-profit companies that you pay a lot of money to them, and their family or shareholders receive some of that money as profits, which is not necessarily a bad thing, but there is this other side. None of the journals listed here, but there's another side of publishing now where some of that for-profit stuff is maybe a little less, less on the up and up. So you want to be a little bit careful about thinking about journals, but again, talking to your group and looking where other papers in your field are published is a really good way to both learn about what's been done in your field and also where your work might fit. So picking the journal is really key, because once you know the journal, as far as the mechanics of writing the paper go, you can go and get a template for their journal style. Many of our papers in physics will write in LaTeX. If you haven't used LaTeX before, it's always good to learn. But there are, for most journals, you can also write your paper in Word. It's going to be very inconvenient if you have lots of references, math, other things. So many of us find LaTeX much more convenient. There's going to be page limits, other constraints in many journals. There's letters often. Physical review letters will have a short page, maybe page limit of like 4 pages, and maybe really hot off the press, exciting work goes into a letter. Longer, more detailed papers might go into a journal that doesn't have those kinds of page limits, like a physical review. That would be the A to B journals, which are different subfields. So you definitely want to know that at the outset, because it's going to very much affect how you're going to structure the paper. Obviously, then you can outline the paper. I mean, you really want to think about who your audience is. Just like anything, you'll probably hear this a lot. Who's your audience for this paper, and what do you want to communicate to them? I mean, what are the things you want other peer scientists working in your field? That's typically your audience for a peer-reviewed paper to learn from your work, And often what I do actually is structured around the figures. You might, if you know how many pages you want, you might have some major results that go in the figures, and I can help you think around what are the things you want to show people visually. Often those are the main parts of the paper. You can start writing your first draft. Maybe you don't even want to start with the abstract. I can come back to this, but often people will start maybe outlining the paper before what is the major message. Definitely stop me. I'm going to go fast just to keep in time, but if you have questions, definitely stop as I go. Okay, so writing style. So you either think carefully about each word before you type it, or just randomly press buttons and hope something comes out. Maybe somewhere in the middle is a good optimization. So what does a paper look like? Again, it's going to depend on the journal, but here's an example paper. This is actually, I don't know if anyone recognizes this paper. Does anyone, maybe if you see this figure, anyone know what this paper is? This is
This is the paper for detecting the first detection of gravitational waves, right?
Yep, excellent. Yep. So this is LIGO's observation of the first binary black hole merger. You can see these chirpy waveforms here. And yeah, they have these beautiful figures sitting right in the center of the paper. It turns out this is a letter, which for everybody else in the world except LIGO is 4 pages. This is a 9-page paper. So it turns out if you do Nobel Prize winning physics, maybe you can convince PRL to let you write even more. But outside those constraints, you can see that maybe major sections. There's some title block in physical review. The paper starts with an abstract, which is a short summary, really high-level summary of what are the main points you want someone to take away if they don't read your paper. There's an introduction, putting the work into context, and then most of the paper is methods and results, and your figures, what are the main things you want to communicate. It's really good to be able to communicate. It's tough when you're space constrained, but anything somebody would need to know to understand and reproduce your work. That's often the bar here. And of course, we always approximate that with the constraints of a real paper. There's some conclusions and outlook. As I said, no work is ever done, even when you publish a beautiful paper like this. This was just the beginning for LIGO. So they have some outlook of what they're doing next. And then in this case, some long acknowledgements, knowledge and funding sources, other resources used, computing facilities, things like that. And then another really, really key part is the references. I'll come back to this, but all work, we saw that million papers building up. I mean, all of our work in physics builds on the work of other people. And, it's an important part of publishing to make sure that you understand the literature that's already there and how your paper fits into it, and you appropriately cite and reference papers that have come before that are relevant. I will say for the logistics of this, if you're using LaTeX, that's great. If you are using LaTeX for your references, you should use BibTeX. I wouldn't recommend doing them by hand. Sorry, all of a sudden I became unmuted, or something happens. Okay. So BibTeX is a plugin that allows you to manage references in a much easier way. And especially if you use a reference manager, which lets you go to a database online and just click a button, download the citation information. It can then just make everything kind of plug and play for keeping track of the references. This can be a mess if you try to do it by hand. And then another really key tool these days is Overleaf, if you're using LaTeX. This is a website essentially that lets you edit LaTeX code, but lets many people work simultaneously. Even if you're one person, you might consider using this tool. I use it even for my single author documents, but if you're working in a team, in a research group where lots of people are editing the same LaTeX, these kinds of collaborative tools are really, really crucial. Okay. So I said the paper starts with an abstract. This abstract, as they said, should really summarize the main results, the few things you want people to take away in like 5 sentences. That's a really easier said than done task. Because you're going to have a lot of stuff to say, right? And you have to sift through that and just make sure you're hitting the main takeaway message. A common strategy, actually one that I really like using, is to actually write the first draft of the paper and then do the abstract. Because as you're working on the paper, especially as I said, like sometimes you're trying to figure out exactly what the endpoint of the paper is, what the message is, and when you get the text and figures in place, sometimes it helps you kind of gel around what the main the main idea that you want to communicate with the paper is. The abstract's really super important because many people will maybe see your paper on the archive or in the journal, They might look at the title, and if they're excited by the title, they might read the abstract, but that might be as far as many of the readers of your paper go. And so you want to make sure you communicate why your work's important there. And have 2 or 3 things that a reader would take away, even if they don't see the paper. This is maybe very parallel. We'll hear about scientific presentations, but you'll also write these kinds of abstracts for a talk. And again, there your goal is a little different, convincing someone to come and hear you give the rest of the talk. But maybe it's a pretty similar strategy, and then you need to communicate quickly why people should be excited about your work. For talk abstracts, you might be less specific than a paper. A paper really, you have results in the paper that you want to say. But in talks especially, I think since this covers paper and talks, I'll just put this in. Sometimes you're submitting an abstract for a talk that you're going to give in 6 months, and you're hoping to have some great research results that don't yet exist. So it's okay to be a little vague in those and say something that will be true whether or not those experiments work out, because sometimes it's hard to look. And yeah, and I think if you take one message away today, like if you want to know how to rate a paper or an abstract or anything like that in your field, because everything has field-specific details, go to the same journal, look at other papers, go to conferences, the previous year of the conference, look at people's abstracts. That'll give you really the best idea of the specific culture of your style, length, format, things like that. So here's the conference abstract. Faculty members saying, I want you to submit an abstract to the conference in 7 months. I have no idea what results I'll have. Don't worry, the trick is to make it as big as possible, and the more ambiguous, the better. And then, yeah, that's why it's called an abstract. It's abstract art, yes. Okay, so let me say one more thing about figures. So I already mentioned that often when I write a paper, I structure it around the figures. I think the figures are really, really important. And the reason is that, maybe people read your abstract, you get them really excited by your abstract. Probably the next thing they do is they go and look at your figures and read your captions. The vast majority of people who actually look at your paper maybe only look at the figures. And so getting across the key ideas, like the picture really is worth 1,000 words. And it's worth your time to make good figures for your paper. That's going to be effective in communicating your research results. And this is a real pain because it takes a huge amount of time to make good figures. That not just you who took the data and know exactly what you're plotting understand, but somebody looking at your paper who doesn't understand all the results, maybe only as a figure caption can understand what the main message of your paper is. So I have a bad plot and a good plot here just for schematics. Maybe these are even field specific, but what's wrong with this bad plot? Does anyone see any issues? Yeah, the title, that's default from root. If anyone uses root, sorry in your research, but maybe you recognize this format. Anything else?
Axis titles.
Yeah, no axis titles. Maybe they're a little small. It's also, this is a bit of a style, but there's not a lot of information in the plot. You're not giving the reader as much information as you could be. I just randomly picked this as a good plot. This is actually a plot from the microdune sterile neutrino oscillation search. There's really a huge amount of information communicated in this plot. There's all kinds of data points and stuff on top of each other, but I don't work exactly in that field, but I can look at this plot as as a parallel in a parallel field, understand what these are. There's a good legend pointing out what all these complicated things are, the axes and the label. So again, it really depends on the style in your field, but this plot to me really communicates a lot of things. And so I think our slides will be posted, but I'll keep going just in the interest of time. There's some general rules that are always true, but then, think about taking the time to make really effective plots. I think they're worth the effort and a good way to structure your publications and your talks. References. So yeah, as I said, understanding the literature in your field is really a key part of your contribution to it. It's never that we're, it's extremely rare that we're doing something completely new that nobody's ever thought of. I've never had that experience in my career. So if you have large bodies of work, as we sometimes do, you want to cite maybe like review articles, reviewing lots of maybe all of dark matter or something towards the beginning of your paper. But then if you're, there's closer work that's more recent in time that your results are building on, it's important that you're aware of that work and you cite it. And there's these tools I said like BibTeX, and then these databases that help you get citations in the format you need to match the journal's format. So If you've never looked at the Inspire data, if you work in high energy database, if you work in high energy physics, that's a really key one. In astrophysics, maybe it's ADS. There's Google Scholar. You can go to these places and get formatted citations that you can plug directly into whatever tools you're using. And this is maybe the main message here. For better or worse, it's really important to understand where you can, within reason, the papers you're citing. Don't just like cite the paper that has the right title. It's really easy to say, oh, I wrote my whole paper, now I have to go fill out the reference list, and I'm just going to like search in the database for random words and pick a few papers. That's really not the way to build your reference list. It's going to help you as a scientist to understand the literature in your field. And again, taking the time to find the right references, make sure you have all the right references is really a key part of this process. Yeah. So, okay, one more piece. It's amazing how many PhD comments are relevant, but yeah, I had references in manuscript. Great. Oh, did you really read these? Yeah, of course. Okay, define reading. Maybe you need to reference the dictionary. So yeah, I mean, for better or worse, like there's many situations where citations are taken out of context and completely don't say what the paper says just because they are not careful with references. Okay. Let me talk about the last step. After you get everything done, you submit it to the journal, or maybe even actually here before you submit it to the journal. You're definitely going to need to revise your paper a lot. This is a hard skill, writing dense scientific papers. And you're going to improve your paper dramatically as you revise it. And there's lots of stages here. So before you submit among your co-authors, if you're writing with other people, your advisor, getting feedback early and often is really important. If you're in a large collaboration in astrophysics or high energy physics, you're going to have some very formalized, probably stringent internal review that might be the toughest review you go through before you even submit the paper, maybe even more than the peer review. So there's lots of processes maybe in the collaborations. And once the paper is ready to go, often you'll submit it to the archive and in parallel send it to a journal. And then independent peers, you don't know who they are, but other experts in your field review it and send you comments. And then you would take those comments and revise your paper further. And in some cases, even after publication, not everything's caught. And somebody might write a comment about your paper or send you an email and might even write an errata to the paper after it's published. And again, this can be a hugely painful and time-consuming process. This is draft infinity here, but it's a key part of getting it right because you never can get it right the first time you write it. There's even yet another revision to comments. Oh gosh, I'm really ready to see this. There's a question. Yeah, question.
What exactly is an erratum? I don't know if I've ever seen one of those.
Yes, so they're rare. They're relatively rare, but if there's a published paper with an error in it and you discover that error, you should write a second paper rather than actually editing a paper, because in the scientific record, the papers stay as published after peer review. You would write a second paper that would be linked to it and called an errata.
So is it like a full second paper or is it like more of a note?
Sorry, a second note. Yeah, so it could be very short. It could be this figure has the wrong units. These are the correct units. It could be one sentence. If it was a more significant thing, it could be a page, but rarely are they much longer than a page. But yeah, it's an important, if you ever discover an error that is in the published record in your work, you should really seriously, often want to write this kind of errata. All right. So yeah, so maybe I'll just leave it here. I think I said a lot of this, this revision process is really important. Once your paper is accepted or rejected, and being rejected is part of the process. We've all had papers rejected. Often what you'll do is submit it to another journal. Maybe it wasn't the right fit for the work. Maybe you need to actually go back and take more data, make major revisions to the paper. But then you can send it again and update it and improve it and eventually get it published. If you get it accepted, the journal will do some proofing process, check the typesetting and everything, and then send you final proofs, which usually happens within a few weeks. And then eventually they'll show up on the journal website, maybe even in print, although these days we may basically see it on the website. And then if you're also posting to this preprint server, the archive, in parallel, you want to update your archive poster with the posting with the final journal version, as well as the reference to the published paper so that people can see it. And then step 5 is this is one in many papers, probably in most of your careers, so you can get started on the next. Okay, so that's all I have. I didn't answer any other questions.
Question for David, any questions online? Seeing none so far, let's move to Bobby.
and Jorge usually who's that in the Mariana group working on Florida and Cupid, is that correct?
That's right, yeah, so I work in the intersection of particle nuclear physics. So I need to share my screen first. Yes. Sure. Oh, shit. Well, I could cancel my.
Oh, now you.
Yeah, but it's okay. I'll just, there's a way to make these bigger, I believe. Oh, I won't worry about it. Okay, yeah, so because most of you, I'm sure have given talks before. Just this is a way of communicating your findings or your research. You know, similar to doing it on a paper, but at least on a talk, you do it fast. Well, you have less time, so you have to really specify what you want to tell people. And again, as writing paper is also an art and it takes a lot of time to make to perfect it. So I guess yeah, is it what I just said. And in this talk, I'll cover how to prepare good slides and plot, how to deliver good presentations, and then finally how to prepare for conferences, which is where you deliver these talks mainly. I guess the main takeaway is as writing papers, giving good talks takes a lot of time, but it's rewarding, and I'll list the what rewards you can get for giving good talks. So I guess I just want to start with crafting slides. So slides are a medium, or the medium with which you will communicate your talk, unless you decide to use a Blackboard. But I think at least in our field, we usually use slides. So an important thing here is that, or I am of this pool of people that think that less text is better, and you want to support your talk by using images and plots. However, this requires memorizing what you want to tell. At some point in your career, you won't have to memorize what you want to tell because you probably have given this talk many times, or you're pretty confident with your ability to talk, and it might just be something that comes out naturally. Sometimes an image, a plot is enough on your slides, but you also need to add what's needed. For example, if you rely on a plot that you did not make. For example, I have this plot here, so this plot. It's a plot that people in the Axiom searches field use. So it's a summary of things, but then you might just be interested in some part of the plot. So for example, if you're working in the lower energies, you might want to cover this section of the plot and just focus on that. And this is just so not a lot of information is shown in that plot, and it's not distracting when you give your talk. Another thing that is important is to resize the images so they are easy to read. So if you did not make the plot, you can use PowerPoint, for example, to cover the axes or to cover the labels, make your labels bigger, for example, or whatever is needed to make sure that that plot is readable for a person in front of you, or that it's far from the projector, for example, or from the screen. Yeah, similarly, make the text big for the same reason. Another thing is that I found important and that I've seen other people do is to be consistent with your slides. So I find it useful to have a template. So for example, here I use a template that has my name, it has the title of my slide, and on the right-hand side of my slides, the left-hand side I usually have text, on the right-hand side I have plots. There are some times where I just have a big plot that I'm showing. So it's important to be consistent so people know where to expect things from your talk. Another thing that it's important, at least for our field in physics, is to avoid equations on your slides, especially if these equations are pretty long. So for example, I have an example here, is the probability of neutrino oscillation. So it has a lot of quantities, it has a lot of terms. If you're not going to explain, it's very important that you explain all of those in a talk, but if you don't, will take a long time to explain all day. So, sometimes it's just better to rely on plots. So for example, this plot shows the same physics as this equation, but you have it in a pictorial way. So it's better to do that. Yep, so don't put equations on your slides. Yeah, some notes on presenting your plot. So this is something that they've already talked about. I think if you're giving a talk, sometimes you might have to modify the plots that you have in your paper. So it's better suited for your talk by either removing some things so you can show some specific points that you want to emphasize, or sometimes the plots that we have in our papers have the labels smaller, or they're smaller so they can fit on the text. But I think it's important that if you're presenting this to an audience on a talk, that you actually make these things bigger so it's easier to read. So for example, one thing is important is to keep it simple. Just add whatever you need to convey the point that you want to convey. This is an actual plot from an actual paper. This is a paper from astrophysics. So there's a lot of things, there are a lot of things that are wrong here, right? And I'm sure you can identify many of them. So the labels are pretty small. There is a lot of information that, it's just hard to read, hard to parse. So again, I don't think this is a good plot on a paper either, but that's another story. But if you want to have a good plot on your slides, you need to focus on some other things. So don't do this. What you want to focus on is make plot labels and the plot text as big as you can. This will help people to actually see from the back of the room what's going on. Sometimes rooms are pretty long, especially in these conferences take part in hotels, and the hotels have very long rooms. So people that are sitting in the back will probably not be able to see your axis. So it's important that you make these labels and labels big. Another thing that's important is to use color-friendly colors. There is a big amount of population in physics who is colorblind, so it's important to make sure that we're inclusive. And Python has if you use Python actually has a dedicated package that makes sure that all your colors are color-friendly. Yeah, important as well. Label your axes, make them big, and then it could be a good idea to ask if this is your first or second or third talk, ask people or ask colleagues about what can be changed. And it will be, important. This can be done when you do a practice talk, for example. So we'll talk about practice talks later. And, here's a plot that I think it's nice. This is from a recent paper from the IST collaboration. So you can see many things that can be identified here. So they really made the numbers big. They did make the labels big. Everything here is labeled. The colors that they are using are actually colorblind friendly, and they are specifying many of the things that they are plotting here, like this plot here. So there's a big change going from here to here. So again, sorry. This is an easy plot, or you can communicate this plot quickly and to the point in a talk versus the one that I showed previously. Regarding crafting your slides, I think slide numbers are very useful, especially when people have questions. Sometimes people remember the slide number. So then at the end of the talk, if somebody has a question, they will ask you, can you go back to slide X? Another thing that it's important when crafting your slides is to cite everything that you're using that is not the property. For example, images, plots that you took from another paper. So you give good credit when it's for those materials. Something that I've been actually learning recently is to use animation to your advantage. So this is important when you have a big chunk of text in your slides. So for example, what I'm doing here, I'm not showing a lot of images, but I have a lot of text. So I've been finding it useful to just have animation so I can highlight something in a particular order. And again, when you similar to your plots, when you make your slides, be colorblind friendly. As a just out of curiosity, about 8% of men are colorblind. When you prepare your talk, you want to have a storyline. I think Samantha will tell us more about this, but it's important to have an outline of similar to writing a paper of what you want to convey in your talk. So it's important to mention in the first slides, why do we care about these? This will be something that will actually keep people interested in your talk and not lose interest in the first 2 slides. So show the main problem and why do we care about this, what we want to solve. Then in the rest of your talk, you have to focus on what you did to solve this problem, or what are you doing if you have preliminary results to try and solve this problem. If you finish solving the problem, how you did it. And then again, you don't want very extremely detailed here because usually these conference talks are say 15 minutes or 12 minutes with 3 minutes per question. So you want to be specific, but not very, very detailed. And then finally, what's next? What are the prospects of the work you did? How can be extended, for example? How can it be connected to other parts of your field? Something important as well is to know your audience. For example, it's very different to craft slides for if you're giving a talk to people from high school or people that just started their undergrad versus giving a talk to, for example, grad students or professors. So it's very important that you know your audience, so you know where to focus on your slides. I would say the first part of your talk, if you're giving a seminar, for example, the first part of your talk should be mainly focused on general things. So things where I would say 100% of the people know you're talking about, and then focus more on your problem where say about 30% of the people will know about what you're talking. But it's important to know your audience. And again, you can find these at the conference description, who will be attending, or if you're giving seminars, you can actually go to the webpage of the physics department, for example, see what who is there, what professors, so you can email whoever invited you and ask, what is my audience? So you can target your sites and your talk better. And something also very important is to know the time that they are giving you and actually stick to it. This is important for both conferences where there is a very tight schedule or when you're invited to give talks. I think it's out of respect to just ask with your time. And then finally, something that I think is one of the critical things here is to practice. So how do you practice your talk? Why do you practice your talk? Sorry, first is that it makes you more familiar with your material, you know where things will be in your slides, and you know what you will be presenting. So this will help you create a narrative of the story, so you can kind of connect it smoother. You can smooth out the flow of your story. It will also be important to calibrate timing. What works for me, again, disclaimer, this is what usually works for me, for different people, but I usually go through my talk for the first time, and for this, I just go slide through slide, maybe writing down the ideas that I want to, or the main points that I want to talk about, and also correct small typos and errors, because again, those all will always be there. And yeah, so think about what you want to convey with that slide, in that particular slide. Sometimes this also helps you to maybe realize that slide is not important and can be sent to the backup, or just it's not relevant, so you can delete it. There are different ways to practice. For me, my English is not my first language, so in grad school I was still learning English. So I had to write down exactly what I wanted to say. This was mainly because I was afraid that I would forget the English word. So I memorized my whole talks. This is not the best optimal way to do it. So at some point your talks will go from 12 minutes to 45 or hour-long talks when you give a seminar. So that might work for you. It requires some more work, but if you feel more confident doing it that way, just go for it. What I do now, I just write down the key points and then develop story or my speech on the fly. I know what I want to convey, or what I want to communicate for that particular slide, and as I'm going through my talk, I just say what I want to say, keeping in mind what I want to communicate. Now, when you practice, be aware that the first run through will be bad, and that's okay. I think this is very common for everybody, unless you've been giving this talk for a long time. So you will be okay that the first time is bad, and just don't feel that this is the end of the world. You can keep practicing. So yes, practice again. Can be one, it can be twice, once, twice, or more times until you feel comfortable. Again, ideally, you would practice an infinite amount of times, but that's not possible, right? So just feel comfortable, practice until you feel comfortable, or you're run out of time. So it'll be better with each practice. Something that I usually do is I time myself. And again, if I don't stick to the time, if I am going above, I delete content. If I am going below the allotted time, it's because I'm usually talking pretty fast. So it's very important that you pace yourself when you're doing talks, especially because physics is also a very international field. So some people, their English is not the first language, so if you're speaking fast, some information might get to the English speaker or native speakers, but not to other people. So it's really important that you pace yourself in that case as well. Again, keep practicing until you feel comfortable. I found it very useful if you are in a research group, for example, ask your research colleagues to listen to your talk. So they will come, you will rehearse your talk as if you were giving it in real time. And then in the end, people will either give you notes or they will ask you to go to a particular slide and give you suggestions about that. So I think that's something very important that I encourage all of you to take advantage of your research group. And something that I also found really important is to practice once within 24 hours of my talk, especially I would say optimally before going to bed. I guess this might not be possible for everybody, but that's what works for me. So you have in your mind, fresh in your mind, where slides are, or like what the content is of each slide, and you have that, right before your talk. Now, when the day of the talk comes, how do you deliver your talk? So you could go quickly through your slides a few minutes just to refresh your brain. Again, this might not be possible if you have to meet with other people, for example. Or this might not be needed if you feel comfortable with how you did your previous practice talk. Another important thing is try to face the audience. If you have a laser pointer, sometimes it's very easy to just move your body and just like always be moving the laser pointer. So that might be also distracting, but it's very important to face your audience and just talk to them. Yeah, I guess don't ever use the laser pointer, it's distracting. Sometimes people forget that they have the laser pointer on and they point it to your faces. Don't do that, that's very dangerous. Always explain your plots. So if you have a plot or a figure, is because you will rely on it to communicate the main idea. So it's very important that you explain each axis, all of the axes, the colors that you're using, what they all represent. And similarly for other figures that might not be plots. Again, it's hard to not be nervous, but everybody, if you're going to a conference, everybody at the conference is going to give talks. Maybe they are also nervous. So, it's the baseline of the conference. So you might want to be aware of that everybody will be giving talks, so don't not feel nervous. And then, something important is just shoot yourself up in your talk. You did a great job. Another thing to keep in mind is that good talks can help you land your next position. So for example, you go to a conference, you're an undergrad student, you go to a conference, you give a great talk. It's very likely that if you're applying for grad schools next year, some PIs will be there, or some people in a particular lab that you might want to apply will be there. They can say, hey, this person gave a great talk. Can we invite them to give a talk, for example? Or when the applications comes, like, oh, I saw this person give a talk. I think this person will be a great person. So, this is one of the rewards of giving good talks. And again, more PhD comments. It's very likely that you plan something, you plan your talk to be a certain way, but it will go a different way. And that's okay. This will help you to plan things better for your next talk. Or maybe it went well, it went out of the course and it went well. Maybe this is another way that you can present your findings, for example. Regarding scientific conferences, again, people are always happy to talk about their research, so don't be afraid to just reach out and say, hey, I really like your talk, but we talk about what you did. Or I'm doing something similar. I have a question for you. And, I think everybody's always very nice and willing to talk about their work. Yeah, ask questions. I think some places allow you to ask questions during the session. Usually it's after the session, but don't feel shy. If you're thinking about networking, either because you want to find a grad school position or a postdoc position or something else, just have an elevator speech. So this is a 1-minute speech where you have the main findings of your research and why it's important, and you can communicate that. I guess, if you're looking for an next position, explicitly mention it. If you're talking to somebody that can potentially hire you as a grad student or a postdoc, say, hey, I'm also looking for a position in case you have a company and you want to consider me. And then another thing is meet people at social events or the conference itself. Sometimes there are opportunities to give talks at other institutions. So if you meet them, and if they know that you're a good speaker, they might invite you to give seminars or talks in their institution. And then finally, I think personally, it's been very useful to talk to people that give good presentations. They can give you more tips. They can tell you what works for them, what hasn't worked for them. So I find that really important. There is this paper in arXiv that I've used throughout my career. Sometimes I think I read it every time I'm going to give a talk. So I read it last night on how to give good talks. This is by Charles Hall. Part of my slides were based on this paper, so you will find a lot of information that I just told you on this paper, and I really find it very useful and very comforting before giving a talk. And something that it's also very important is to sign up to present at journal clubs or internal seminars. Again, journal clubs, internal seminars are in your own institution, your peers. Most of the time, everybody's really nice and useful, or most of the time they are your friends, and you can actually ask for advice to them on how to present if it's your first time, or if you've done it, you have done it before and you want some feedback, you can ask, hey, how did I do here? And again, this is a very friendly environment where not a lot of stakes in play, and this will help you to practice your skills. Yeah, and that's pretty much what I have. So I'm open for any questions if anybody has any.
Questions at this time? Anyone?
It was a good talk.
Yeah, very good. Okay. Samantha, again, Samantha is a graduate student. I believe also in the Mariama's group working on Quora and Cupid.
Yes. Okay, can you take my Zoom just disappeared?
Yeah, I can do it.
Okay.
I think. Like stop sharing other stuff.
Hey everyone, I'm Samantha. I'm currently in my 5th year as a graduate student, starting my 6th year, and I'm writing and applying to jobs right now. So that is kind of where I am at in my life. And then I was given the topic of communicating with about science. So we heard a lot about scientific presentations and papers. So I'm going to take kind of the public sphere of this. Everything else you can do is science communication. So I guess as a start, I wanted to talk a little bit about what is science communication. And the definition I tend to take is the broadest definition possible. So I like to say the practice of informing a specific audience, so you know your audience, about science related topics. And this can be scientists talking to other scientists, but then it can also be scientists talking to, like children at schools or people in, like Washington DC who make laws and policies, or even like the news, the general public, and all types of scientists do this too. So for this talk, I'm gonna focus more on the question of like, how would you describe research or even like the major in what you study, to someone you're sitting next to in a grocery store who's not in a scientific career, someone in high school, a kindergartner, Congress. And at least to me, like my personal philosophy is, as a scientist, a lot of my funding comes from like tax dollars and the public. So like any chance I get, I am super happy to share like what I do, why I think we should study it, how it affects people's lives, and how that can affect like policies and things can have very real impacts, like society and life too. So for a couple of, I think similar to Dave of when he said like, oh, you can look at papers and this gives you a good idea of how to write a good paper. I think like just being aware of different like science communication that people can do is like gives you an idea of what you could do and different opportunities there. So I went on Write Lab's Instagram, and something I like deeply admire about this community is I think there's lots of great like science communicators here, and a lot of work gets done. So this is just over the past couple of years, some examples of science communication, like just within this lab. Professor Sarah Demers has talked to the media about the Large Hadron Collider and finding things there. I talked to her and she's gone through really cool media training before. Professor John Harris has been on ESPN video. You know, cool postdocs, graduate students and professors from down to DC and talked to different people in Congress about like specific laws and policies and things like that. Write Lab does a lot of outreach. So basically this is a picture of the solar eclipse and talking to people about science and what gets you excited about science and different concepts. There's been lots of like science and art collaborations at Write Lab too, and also scientists talking to other scientists about their work as well at conferences. So I put together a list of like science communication opportunities that you can have like right now as a researcher. So even just like as a grad student where, you know, my full-time job is research, there's so many different opportunities to like communicate your science to the public. So I work on a research collaboration, and there's lots of opportunities for like outreach and talking about the publications that we're putting out. There's different conferences that either focus specifically on science communication that you can get opportunities to go to, or sessions of conferences like the American Physical Society April and March meetings, which are big meetings. They always have sessions that are focused specifically on science communication and like different techniques or things people have done. I think at most universities, there's lots of events that you can participate in, like 3-minute thesis is a popular grad student one where the whole idea is you try to condense your thesis down to 3 minutes for a public audience and share it. A lot of times there's also like scientists interact with the media a lot, and even social media to explain like really new developments and results. Lots of groups work on science communication, a little bit already about like outreach talks minutes. And then I'll also add like even just as like a citizen or someone who is like in the country working, you can write to your legislator about either like science related bills, you have scientific expertise, you are more than welcome to share that, provide testimony on bills, go to Capitol Hill days and lobby. Like there are so many opportunities to get involved in lots of activities. So let me share a little bit about like what I've done with science communication. If you have like any questions, so you have a better idea of maybe what I can speak about, and I talk to people who've done like many other types of science communication too. But for me, this kind of started. I did some teaching in undergrad and really loved it, and then got to grad school, kept loving teaching, and then got involved in quite a few like outreach projects when I first joined. And from that was like, oh, like this is a part of science that makes me really happy, and I want this kind of to be more a part of what I do. So I guess midway through grad school, I did like a 30-minute thesis competition and got a public communication certificate through our like teaching and learning center here. I got to learn a bit more about like techniques and some actual theory behind that in practice. I got involved with one of our student groups here and did a couple of what we call like science in the news talks, where I went to like libraries and talked about science to just library patrons. I talked about the nuclear physics basically in the kitchen, which was kind of a fun talk. And then kind of later grad school, I joined the outreach board of my scientific collaboration forum, and through that, like I've worked with journalists, helping like edit and write press releases for our scientific results. I worked with a web designer for building a new website. I worked with an architect to make this like giant poster of our experiment that's like outside of it now, so people taking like public talks can see it. I got to go to a science writing conference, which was really fun. And then I became a director of the group that does these science talks. So I got to do a lot more like editing and directing of science talks as well. And then I guess like up next for me, as I said, I'm applying to career, so I'm still kind of deciding exactly what I want to do, but I think I know I want science communication to be a part of that. So whether that's I do a postdoc and continue to do science communication type things, or I've also kind of dually applied to like science communication careers. So if anyone has questions about that, I'm happy to share my experience there. And then I would love, like, if I had more free time, I'd want to do like more freelancing of like great science stories for kids. It's one thing I really like. Like I have like nieces now, and it's, I don't know, to me super fun to explain science to like that age group. So I don't have that much time to go into like all of the different topics in science communication, but I thought I'd give kind of an overview of different themes. And of course, there's so many different types of science communication. So again, like you could take classes and classes on this, but I think the big themes to me are, number one, as I think everyone on this panel said, is know your audience, and your audience can be very different things. Like they're, you know, Congress, kindergartners, like lots of different starting places. Depending on your audience, you always want to either like remove or explain jargon that we use kind of as scientists to each other, terms that people might not know. There's lots of techniques you can do this, like backwards design is the idea that whenever you give like a talk or writing something, your first step is kind of like almost like an abstract, but think what is like the one thing you want people to walk away from this like piece of science communication with. And that's what you decide first. And then you build everything else just around that one message. Is like a technique that you can use in science communication. And then I think the fourth one is storytelling and narrative progression, which I'll go a little bit more into. But basically what I wanted you to get from this is that I think like science communication is a science, like people actually study science communication and what's most effective. You can go to grad school for that even. And then it's also an art. So I think there's a lot of room for like creativity and what you like to do. And just like any artist, like finding your own style and how you like to do that too. So I was just gonna go a little bit more in depth on storytelling. So I have references here if you want to like read more about this from people's perspective and how to do it. One of the references even calls storytelling the soul of science communication. But a ton of science communication research shows that like storytelling is one of the most effective ways that humans communicate to each other. Like this is how we've like communicated for a very long time. This is kind of one of the most effective ways people like walk away from a conversation remembering things. So just like stories, like, you know, that you might read in like a book, like a fiction book or something, science and scientific stories can include like background, conflict, characters, plot, even if your characters are like keeping data or something like that. So if you think back to, we've taken an English class and ever talked about like the hero's journey or the Cinderella story and all of those plot lines, those are actually things you can use like giving a scientific talk or writing an article for a newspaper or something like that. So on the right here, this is something fun that someone in the science communication group once told me, but this is Kurt Vonnegut's overview of kind of 8 different types of stories and plot lines that you can write. This was a master's thesis that actually got rejected by the University of Chicago. And Kurt Vonnegut's like super famous author, so kind of a fun story there. But you know, there are lots of different ways you can tell stories, and you can even use this to tell scientific stories too. And then I guess one of the last things I wanted to talk about too is if you are like thinking about careers and like, oh, I love science, but maybe I like being more on like the science communication side of this, there are also people who are full-time science communicators. So there are like content creators, those can be like artists and writers where they present science. This can range from like super technical, like technical writers or medical writers to things like pulled for the public. Lots of educators are science communicators, so whether they work in like museums or write books or articles, lots of people employ educators to do this. There's a whole range of like political advisors or advocates that are also science communicators, whether they work for nonprofits or politicians or agencies directly. And then, of course, there's also reporters and journalists, like science writers and science journalists, and that is available too. And also there's like multiple fellowships to get involved in this, like AAAS, the American Association for the Advancement of Science, has a mass media fellowship that I think undergrads are eligible for, where you're like placed in newsrooms for science and you can get a taste of that. There's also like full graduate programs on all of these paths. If you're like watching this and like, yeah, that's something I'd really be interested in. So to end, we probably don't really have time to do this, but I think this is a fun exercise. I've also been told like the way to get good at science communication is just to practice it. I think a fun exercise that everyone can go through is, if you think about your own research, try to like write a sentence or two, your main takeaway of your own research, for what you would tell an expert in your field, an undergraduate student in your field or in your same major, like a friend or a family member who's not a scientist, and then a kindergarten. I did this with my own research. If you want to go back and kind of look how you change like the jargon and the message, this is not a perfect way to do this. There's many things, but this honestly took me about an hour to do the first time I did it too. So this is just to say, like, again, this is something you can practice and you get better at, but I don't think by any means it was especially not easy for me to write, like, what would I want to tell a kindergartner about my research? So that's just kind of a takeaway activity, but I also put up a ton of different resources for more information on like science communication and some of my favorite like podcasts too that I think will be sent out at these slides. That's all for me. Thank you.
Any questions for anyone at this point?
You're getting these slides, right?
Yes.
I have a question for Dave. Dave, so the profit and non-profit papers, is there a difference? Say, if you submit your article to profit versus non-profit, how likely is it that it will get accepted, or do they have the same standards? And
I mean, I think there's two classes of for-profit journals. There's the very scientifically rigorous for-profit journals of Nature. Many of the Elsevier, however you want to say those journals, are very rigorous journals, but still at a for-profit company. And I think there's no real change in acceptance whether you send there versus a non-profit journal. But maybe some of the fees that are coming out of your publicly funded research grant are going to make profits for that company. There's a whole other class of for-profit journals that are and there's a spectrum, unfortunately, so it can be hard to figure out where on the spectrum a journal on the edge might live. I mean, there's these some very, some journals where they are trying to get a lot of papers published and they will publish almost anything. And many of the journals that run journals and stuff like that are for-profit enterprises. Okay. So if you're not sure about this, you can Google predatory journals. There's this list. I mean, it's something to be aware of. Sometimes these journals will also email you and say, you did great work. We want you to write a review article on blah, blah, blah topic. Many of those things are bordering on scams. And sometimes, especially near the middle of the spectrum, it's very hard to tell. So talk to senior people and even some senior people or people who have a lot of experience have different opinions on certain journals. And then there's some that are just like completely scams. Thanks.
So we have a question for Samantha. Could you talk more about the SciComm paths for graduate students?
Yeah, absolutely. Any particular aspect of that, or just what you might do as a graduate student after?
Eugene, do you want to clarify? Just generally coming from a current.
Yeah, absolutely. There's a couple of different ones. I know a lot of people that I've talked to who have like transitioned into a science communication role after grad school. There's fellowships specifically that can help with that are usually kind of made for PhD students. So like the AAAS mass media one is one that I've heard a lot of people do, where you're basically get some experience as like a writer and can transition into like a full-time writer with that. I've heard of some people go back to graduate school, but you definitely don't have to for like a 1 or 2 year master's in like science writing or medical writing or something like that. I know if you have science communication experience, I've also heard of some people like after graduate school or postdocs, even going and working for universities and like their communications department. If you have a little bit of like journalism experience there, those are like institutional writers. Again, like different agencies also employ scientists to be communicators in different companies and things like that too. So I think there are really so many different paths. Like I think the hard part about this that I found when like thinking about this too is there is also no one path. Like it's not like, oh, you do a postdoc and then you apply for like faculty positions. Like there are no straight paths because there's not like one science communication career, but there are many options to get there. And I think it depends on like what you want your career to look like too.
What are the criteria for like being first author versus like some other author on a paper? More, I mean, I get like the first author part, but like, how do you choose?
Yeah, I mean, I can take a step at it on permission term too. I mean, there's no algorithm, of course, but I mean, typically the first, and there's also very field specific cultural things that affect authorship. So I think the first thing to do is to go read some, like if you're submitting to a journal like the APS, American Physical Society journals, the PhysRev journals, they have a whole page about authorship, how to think about it. And they will not give you any hard and fast rules either, other than to say it's a little bit cultural. In our field of particle and nuclear physics, for short papers that maybe aren't a huge collaboration of hundreds of people, the first author did the bulk of the work or most of the work. And then we order people non-alphabetically by somehow assessing what their contributions were. And then often PI or senior people are the last authors, which somehow is also a special role on those lists. But then in many of our, like I work in a large collaboration with 200 people where every author list is alphabetical. And there's author guidelines developed by the collaboration for when people qualify to comment on and off that list. So it really depends. I mean, the basic guidance is that anybody who made a significant contribution paper is an author, and roughly the order of authors delineates, the order of contributions, but there's no perfect way to do that in the document.
I think I've also seen where they have a sub list, like the first author and other people contributed, and then they have another list that's alphabetized. Those people are contributing, but in a different way.
Yeah, so some of our collaboration technical papers are like that, where the people who really did the work, maybe on a technical paper, not a scientific result, would come first, and then there'd be an alphabetical list of all the people who qualify. That's, I would say, a quirk of some collaborations that not all collaborations employ. Like the LHC papers, there's 2,000 people always in the same order.
In terms of like the more public aspect of science communication, how feasible would you say it is to like do both? Like if I'm really interested in doing like big cool lab work where it's like very technical, very scientific, but also I want to explain to kindergarteners how my work is, like, is that like, will my job be doing the technical work and then I have to go find opportunities myself, or are there jobs in the field where it is both at the same time?
I think it really depends on like what you want your distribution of time to be. Like there are professors who are awesome science communicators and are doing full-time research, but talk to like a lot of podcasts and write articles themselves. same with like graduate students, like I know graduate students who full-time research, but also, you know, have a component of talking to kindergartners and doing things like that too. I've heard of some positions where it's kind of a 50-50, like, I think they're not that common, but I've heard of some people who like half their job was research, half their job was outreach. Katie Mack, who's a really famous science communicator in the field, I know she had like one of those positions that helped her get started as a science communicator. The last time I talked to her a couple of years ago was in one of those positions, but not that common.
Podcast with John Green.
So actually, yeah.
I think some of the fields that require outreach is that, right, the
Yeah, so I mean, as a student or a faculty member, that might come into your research career differently, but yeah. For the Natural Science Foundation, especially in some of their grants for early career faculty, they're, you know, part of your funding covers outreach activities, science communication broadly. And part of crafting that grant and being successful in getting that grant is spending some of your, you know, maybe not the bulk of your time, but some of your.
What does the political piece look like? Like people who are, you know, speaking to lawmakers or lobbying for different things, like how do you get into that?
Yeah, so I would say like science policy is like a whole career in and of itself too. There's also a lot of policy fellowships. So there's a AAAS Science and Technology Policy Fellowship that you can do after graduate school, where you can be placed in honestly any of the 3 branches of government. So you can work in the executive branch and be in an agency, and kind of be more of like a science advisor. Some people do research for agencies too. You can work like for a politician on like staff and kind of be the person that helps like translate it and try to think through how that policy decisions. I think there's also maybe some people, if you have some like more science law experience, that, you know, there's like lawyer scientists too who go to law school. So like that's also a whole field of things, and people who work for nonprofits and like lobbyists as well.
One question?
Yes.
Okay, hypothetically, we're doing research and hypothetically we want to take said research to a conference. What's like the process for doing that? How early do you have to start and like where do we get funding for that theoretically?
That might be a question for you, Dave.
Yeah, I mean, I can try. So again, like if you're working in a research group, I mean, the place to start is talking to the advisor, research advisor. I would say most folks presenting research from Wright Lab or in astronomy are paid, their trips and conference fees are paid by their research group through grants. But there are other opportunities beyond that, right? So, I mean, plenty of fellowships, especially as a student, to go to specific conferences. So if you, I think, the very first step is to figure out what are the conferences in your field where your research would be, you know, where the audience you want to present your research to be would be. There's some sites that list all the conferences, like in particle physics, that Inspire site that has the references also has a list of essentially all conferences. There's kinds of places you can Google for it. And then once you know there, you can see if there's travel grants for student presentations, talk to your advisor, some fellowships and things like this come from travel money. So there's lots of opportunities and no algorithm, but the probably the key step to get started is to figure out like what conferences are the interesting ones to go to in the field.
Yeah, I would add that if you're involved with any undergraduate societies, I think some of them have mailing lists, and usually the conferences have a component that is undergraduates only, so either presenting posters or giving talks. So I would suggest checking those as well. Some of the conferences are exclusively for undergraduates as well. I think the Society for Physics students or something like that might have just those, but yeah, just checking with if you're not part of the mailing list for those. I would check those.
Yale Physics is very involved in both the Society of Physics students and QVIP, which is a conference for women in physics. So you can look those up on our website and see those options. And I think also an acronym to look for is CEU, which is conference experience for undergraduates.
For QWIP, it's fun. It's also very good as like my first conference kind of thing, because it's small and you can talk to people a lot easier.